This Airbus is an A310 model. It has been developed in the late 1980s, and it's one of the most modern equipped aircraft. It has electronic flight instruments and a lot of automatic monitoring, equipped with the latest type of flight management computers. And I'll try to explain briefly to you different parts of this aircraft and how we deal with problems if they arise in flight. This is our primary flight instrument. It's an artificial horizon. As you can see, the horizon here is exactly the same as the one we can see right up front. But sometimes we're flying into the clouds, so we need a reference, and we use these instruments to fly through the clouds or when the visibility is bad. Next to the artificial horizon, we have the speed tape. It's the actual speed, indicated airspeed of our aircraft. On top of our artificial horizon, we can see the modes in which the autopilot is flying. We are actually in profile Mach, profile altitude and navigation. That means that the autopilot is flying the route we have put into the computer and is maintaining the speed which is given by the flight management computer. Other instruments are altimeter, vertical speed and navigational equipment. This navigational map depicts the route we're actually flying. We're flying from Nice now to a point which is called Étoile. Étoile actually is the point where we change from the French control to the Algerian control. This routing is given by the flight management computer. Each point along the route is fed into this computer, can be called at any time, and we can order the autopilot to fly direct to any point which is in the route. In fact, we could fly now direct to Lagos if that would be allowed by the control. But mostly the control will give us special predetermined points to fly to. A special and unique feature in the aircraft, this aircraft, is what we call the ECAM. This system allows us to call all different parameters of the aircraft, all different systems, and monitor them and see if they're working properly. Let's go through all the pages that we can call up. We have first of all the engine page. The engine page represents exactly the same parameters as we can find here, but in more detail, and if something goes wrong, it will start either flashing or going over into amber and red if it's over the limits. Next page is the hydraulic. We have three different hydraulic systems, the blue, the green and the yellow. They all three work independently and control mostly the flight control systems. Next is the electrical. We have on board our aircraft two generators, one by each engine, and a separate one which is called the APU generator, auxiliary power unit, which can be started in case one of the two engine-driven generators is unserviceable. The DC system or direct current system is fed through three different transformer rectifiers and provide direct current for different systems in the aircraft. Next page is the bleed system. The bleed system, in fact, is the air that we breathe actually. The engine is providing the air just to keep us alive. As you can imagine, at 35 or at 33,000 feet, there isn't enough air to breathe. So compressors are sending fresh air into the cabin, making a ventilation and giving you the oxygen you need to survive. The air conditioning panel tells us what is the temperature in the cabin, in the forward cabin, the mid cabin and the aft cabin. We can control through different knobs the temperatures in the cabin as well as in the cargo compartments. In case we have live animals like dogs or cats into the cargo compartment, we can even there control the temperature. The pressurization, as I told you, the aircraft is pressurized in order to give us enough oxygen, and this tells us the situation of the pressurization of our aircraft. In the fuel page, we can see the distribution of the fuel over the different tanks. We have two wing tanks, an outer and an inner wing tank, and a center tank. The center tank being, as the word says it, in the middle of the aircraft, and actually the center tank is feeding now the fuel to the two engines, engine 1 and engine 2. When the center tank is empty, automatically the fuel will be pumped out of the inner tanks. When the inner tanks are empty, automatically the transfer will be done to both outer tanks. This is the flight control page, and it tells us that all flight controls are in the exact position the way they should be. The doors, the different doors of the aircrafts, the forwards, the overwings, and the aft doors. All doors have what we call a slide. They are used in case of an emergency evacuation to get the people as quick as possible out of the aircraft. Those slides are armed in flight, and on the ground, when the aircraft is parked, the slides will be disarmed. Then we have the different wheels on the aircraft, the wheel page, and it tells you what is the actual temperature on the wheels. In flight, the wheel temperature will go down to about 10 or 15 degrees. But on the ground, when we are braking, the temperature of the wheels, of course, will increase. And wherever we go over the limit, the temperature warning will come on, and the crew will be advised of the problems ahead. Now, another page here is called the memo page and the status page. Whenever something goes wrong in an aircraft, in this aircraft, this page will tell you what is going wrong and what is the correct action to be performed by the crew. Let's give you a little example. Let's say that the center tank pump is US, is unserviceable. Whenever this pump is off, automatically the warning bing comes on, the fuel page comes up, and it tells me center tank left pump off. What is to do? Open the fuel crossfeed. When we open the crossfeed, when it is done, the checklist disappears, telling me that the procedure has been performed correctly. So we will now restore everything to the normal condition, and everything will disappear, telling that the problem has been solved and that we're back on normal working conditions. This is the flight management computer. The flight management computer gives me all kind of information about the performance of the aircraft, about the navigation we're actually doing. I can ask him whatever. I can ask him what is my distance to Lagos, what is the time remaining to Lagos, what is the fuel. We have what we call a fuel page. What will be the fuel when we arrive in Lagos? How many extra fuel will I have? How many hours or minutes will I be able to halt in Lagos in case something goes wrong? When do I have to go to an alternate airport? So all kind of information is fed into this computer. Over here we have the radio panels. With those two radios,